right? And that's why threads, they will be blocking call, and until they are unscheduled and another thread is loaded, that CPU cycle is going to get wasted waiting for a slower device to return a response. We create multiple threads using a new thread state, passing it function value, and passing values to it using an object form and converting it inside this thing. We saw a couple of thread synchronization technique using auto reset event. A thread, if we draw parallel between a thread and a restaurant, we can say that a thread probably is a chef, but then that is not the best use, because the way threads are created, a chef would start continue waiting in front of a recipe till that recipe is done before it can serve to other customers. Now, if you want to solve this problem, you will have to hire multiple chefs so that they can cater to different cooking requirements while the chef himself is waiting for the food to be ready. To solve this problem, .NET has introduced another programming construct, and it is called task. Now, a task is more like a small piece of activity which is generally going to deal with an IO activity. Now, because IO activities are slow, the task, when it issues the IO activity, it would know that this is a slow activity, so it's going to trigger the activity. It's going to set a marker of what happens, or where do we go when the task is completed, and we return the control to the calling function. And when the data arrives from that slow device, it is going to resume the execution. There are four there are four aspects to it, two keywords and two classes that are available to us. Async is something with which we're going to modify a function which is going to do a slow IO activity. Await is where this actually sets the marker and it is going to return when the activity completes. A task is that unit of work which is not going to return anything. If you are expecting an output from the task, you will have to use the generic version of it, which is task of T. We saw multiple ways of creating task. The easiest is task is assigned to new task, and you give it a lambda, an action member. With task.start, it is going to start the task. With task.wait, the object.wait, it is going to start waiting for the task to complete. When the task completes, the asynchronous operation has been executed. With task of t, we get another member, which is t.result, the result object. The result is going to save the return value from that particular task. All right. So with that, let's begin our discussion for today. A couple of weeks ago, we studied databases very extensively. Now, databases are two types, relational and non-relational databases. But what we are going to do today is we are going to extract out what we are saving in those databases into our .NET program, right? Generally, the setup is going to be that your .NET program is running on a separate computer and the database is running on a different computer. The way communication happens across different machines is through a network. If it is in the same network, it will happen over LAN. But then it is very much possible with the advent of cloud that you are going to have to cross the internet boundary, and your data will be sitting somewhere on the internet, right, on a cloud platform, right? So our application should have an ability of connecting to databases uh, across LAN and across the internet. There is a network protocol that SQL Server uses, and I think it is called the TDS protocol. Now, this protocol is based on IP address. So, depending on the IP address of the database, there will be a connection established between your computer and the DB server, and it is through this communication that the entire data set is going to get exchanged. What we store in SQL is uh, based on what we saw, that SQL Server is DBMS. Now, this DBMS is going to store information in files and folders internally. I'm not sure of the format that it uses, but if we want to access the data stored, we are going to have to run through a DBMS, right? So when we issue call, the DBMS is going to refer to its internal format. It is going to use the TDS protocol, and it is going to create a package of the response that we are going to receive on the other side of the network, like mostly, and we are going to convert it into a C# like format, right? We are going to have our integers and string variables over here. Now, this conversion is very trivial, and there are multiple frameworks that are created for accessing this kind of data. I'm not sure if you guys have heard of it, but then it was ADO.NET was one of the frameworks. Now, ADO.NET is going to require, so this is sitting on a different computer, it is going to require a connection string, right? A connection string mentions the name of the server, it mentions the name of the database, and it mentions some security information as well. Once we provide this connection string to a framework like ADO.NET, it is going to go on the internet, on the wire, and it is going to establish, based on the values here, it is going to establish a connection to the database in your LAN or probably the internet. With this, uh, with this connection established, now you will get options of querying tables that are available over here. You can perform all the CRUD operation that we saw in the ML section, right? You can also provision databases like creating a new table using what we saw in the DDL section, and you will be able to add tables to a database using these frameworks. Now, ADO.NET will using ADO.NET you will be able to access the database, but it is going to require a lot of groundwork. You will have to select individual rows and convert them into different data type based on the column name, and you should have some intuitive knowledge of the columns, or the word that we use during database design was these are attributes by the chord rules, and we started calling them columns, right? You should have some intuitive knowledge that this column is only going to store numbers and this column is only going to store strings, and this is the datetime column, and you're going to have datetime formats over here. When you read data using ADO.NET, you will have to do a lot of these manual conversions into C# type, so that your objects, they are safe and they represent the same value it is that is saved in the tables as well. There is another set of framework which is called the ORM. Now, ORM stands for Object Relationship Mapper. Um, it does mapping of the object and the relationship to give you these objects, and it takes away the manual conversion of information saved in tables into the .NET object, and this is where they become very powerful. Entity Framework is one such ORM that makes the job of connecting to databases extremely straightforward. So, to make a case for Entity Framework, I'm going to go back a couple of chapters and discuss the concept of solid principles. Now, we understood that single responsibility is about one class doing exactly one thing. If we fail to do like if we violate any of these principles, we go ahead and start adding a layer of indirection. So initially we were writing on console like this, but then we were like, we don't want to connect to a console all the time, we would want some flexibility, and then we went ahead and created a message reader and a message writer, right? An extra layer of indirection is going to make your code extremely flexible, And we saw how the Hello World program kind of improved when we started adding the interfaces. And it also goes back to our discussion of doing object-oriented programming the right way, where you would have an interface, you would have the main program, you would have an interface, and we will have a complete implementation. But then this complete implementation will be connected to the main function through this layer of abstraction. It could be interface, it could be an abstract class, or it could be a class itself. But then this main function is not directly going to have an instance of this. It is going to work through the reference of this abstraction. This abstraction for databases is ORM, but then they all are coming through something called as enterprise architecture patterns. So Martin Fowler is a renowned computer professional programmer. He's an architect. He is probably also co-founder or the CTO of a company called Mindtree. Okay, I am forgetting the name of the company, but he's a CTO in a company, and then he has done some great object-oriented enterprise architecture work late in 90s and 2000, and he is also one of the founding member of the agile methodology of creating applications. So most of the designing that goes into creating enterprise application, it relates to one of these about 40 patterns that he has created and written extensively on his blog on martinfowler.com/EAA. It stands for Enterprise Application Architecture. And this catalog lists all the 40 patterns and provides some initial introduction to those patterns. Just to give you a brief hint of what that work looks like, we all know what MVC is, like ASP.NET MVC, and it is a pattern for creating disconnected, loosely coupled component ways of web applications. So MVC is a pattern that he has, if not invented, at least have extensively written about it. I'm sure there were other versions of MVC present in other code as well, but he made it popular through through his book and writings. So MVC is one such pattern. Then last week we saw a design pattern called singleton. Now singleton talks about having only one instance of an object in during the life cycle of an application. The equivalent pattern in the enterprise application architecture world is called a registry. And so the way this website works is that it's going to have a single line definition of all these patterns. And the registry says a well-known object that other objects can use to find common objects. Right? So you are never going to create a singleton yourself. You are going to create a registry, and that registry will be used to find the common objects that you would want to use. We saw an example of a precedent, but the place where you're going to store the precedent object is inside a registry. Right? And then if you read through this, you will find out that it is, in a way, talking about how to replace a registry with how to replace a singleton with this registry pattern. This is just a brief introduction. His book has a lot more detail about how to use and where to use these frameworks and technologies. Another pattern is if you guys have did any data programming, there is something called as active record. These active records, they are data table and data rows. They are coming from this active record pattern. The entity framework that we're going to discuss today is actually a summation of multiple patterns from this catalog. One such pattern is called unit of work. The other pattern that is called the repository pattern. Now, these patterns, they are broadly categorized into multiple sections, and notice their name. It is like we saw the factory pattern, which is going to create object for you. We saw behavioral pattern, and we saw structural pattern. So structural pattern are about structure of an application, where we saw the adapter pattern. Behavioral pattern is where we saw the strategy pattern, right? And factory pattern is where we saw singleton and the factory method and abstract factory pattern. Likewise, enterprise application architecture patterns, they are categorized. So unit of work is more about behavior of the application, right? Repository is about mapping. So there are going to be two entities, what we discussed here. One mapping sits inside a DBMS, and the second mapping is the .NET code that we are going to create. Now, when we want to link these two, frameworks like ADO.NET, they are good at, okay, they will let you connect to a database, extract values out of it, and create a .NET object, which you're directly going to consume. But then, if you consume it this way, it is like writing "Hello World" program using console.writeline, right? And we saw that once you lock yourself into one way of doing things, you will lose the flexibility of switching from, say, console writer to a Facebook writer. To introduce that flexibility back, you will have to introduce an extra layer of mapping between the database and the .NET object. And that mapping is done using a repository pattern. So let's look at the one-line segment of the repository pattern. I'm going to break this sentence into multiple understandable chunks. It mediates, so mediate is a keyword, between the domain and the data mapping layer. Right? Domain itself probably, okay, I'm going to say that domain is the .NET code, and the data mapping layer is anything that is helping us connect to the database, right, where the data persists. Right? So there's going to be a mediator which is going to map our domain, our .NET code, to a database. Now, very soon I'm going to change the word database to something called as persistence, but then for our discussion we can leave it database. A mediator that sits between domain and the mapping layer from that persistence using a collection-like interface. Now, we saw at least three types of collections. We saw IEnumerable, ICollection, and IList. Right? So there's going to be one of these three present, and it is going to be part of the mediator. And the intention is accessing domain objects. Right? So a repository is going to give us access to domain objects, and the way it is going to do this, it is going to create uh, it is going to create list, and this list is going to be a mediator between the entire pattern is going to be a mediator between domain and where we are going to extract the data from. And then if we continue looking at this diagram, these diagrams are, by the way, UML diagram, and I think this is a sequence diagram. I get a little confused between those 9 to 10 types of UML diagrams, but they are extremely important when you are designing some serious application. So there is a person, right? A domain object. There is an in-memory strategy of how you're going to get that person or list of people inside the memory. This is where our list is going to sit. The repository is the pattern which is going to mediate between domain object and the mapping. So this is where list is, this is our domain is, the repository is the mediator, and on the other side of it, we have a client. Now this person, okay, this person could represent a .NET code and uh, a table in a database as well, but that's the whole objective. The client who wants to get access to a person is not directly going to jump and talk to the person directly. It's going to go through a repository, right? We are going to see concrete examples of how this repository is going to work, but I want you to remember this concept that you don't want to connect your end consumers with the direct service. It is like console.writeline hello world. We don't write our hello world like that anymore. Alright, so a repository pattern is going to do all of these things. Let's look at, I don't know if there's a class. Okay, so there's no class definition. Now, let's look at what unit of work is. We're going to once again read the one-line definition, and we're going to try to divide it in different categories. This says that maintains a list of objects. Okay, there's going to be a list of objects that is affected by a business transaction. Right? So as we are working on enterprise application, we are going to do addition and subtraction. We're going to add to database. We're going to remove things from database, and those business transactions, they need to be persisted, right? And that persistence is going to get maintained by this particular list. Now, it does not talk about a layer of data mapping or data persistence. It says that I'm only going to do the maintenance job. So the business transactions, they're going to get maintained through a list. And by maintaining that, it is going to coordinate the writing of changes and the resolution of concurrency problem. What this statement essentially says is there's a database. The database is going to have different ways of arranging tables and rows inside those tables, and we are only going to deal with DBMS, right? This DBMS will be accessed through another system. This system probably is a server code that we are writing, and there'll be multiple clients. Some people accessing it through phones, some people accessing it through laptops, right? There will be some web APIs that are going to want to access our data. When there are multiple entities that are going to access this data and they are going to perform business transactions, the CRUD operations, right? These CRUD operations, we are going to take away the ability of writing, and we are also going to do concurrency problems with them. So if two entities, like the first entity and the fourth entity, they want to modify a single row, it is definitely going to go through our code. And that code, which is going to coordinate all these things, is called unit of work, right? So these are two patterns that is going to ensure that the data that you're trying to save is protected, and we are not writing tightly coupled hard-coded code like console.writeLine. We are going to add a couple of layers of indirection before access to the data is provided. And the reason we are doing that is because we want to control writing and we want to solve concurrency problem between these entities. Okay. When you understand this, you will realize that when we go into the code, that entity framework for us is implementing these two patterns, the unit of work and the repository. There are more patterns that I can show you in this entire list of 40 that it is also going to implement for us. I'm looking for a repository, alright? So the repository is going to take care of that for us. It is also going to do unit of work. Let's look at another pattern which is called data transfer objects. Right? A data transfer object is an object that we're going to pass around to multiple functions and multiple components of our solution, and it is only for one intention, that we want to avoid carrying data through function calls, right? And this is where, say, structured programming like C and object-oriented programming like C#, they are different. If you want to do anything in C programming, you will have an option of struct, but the object management, the state of those objects, it'll be very difficult to manage. See, object-oriented programming, it makes it a little straightforward that you don't have to write a lot of functions. We are going to maintain the state of the system inside objects, and we're going to pass around those objects as we are progressing through the application. So we're going to use data transfer objects, and if you remember our discussion in the database section where we talked about entity relationship diagrams, ER diagrams, and designing entities, there is another pattern, probably it is named foreign key. I'm not able to. Foreign key mapping, right? Does this diagram look familiar? That there's an album has artist. We created similar diagrams when we were doing, say, normalization, when we were doing entity designing and entity relationship diagrams. Our code of .NET side, it is going to have foreign key mapping as well, and this foreign key mapping is going to let two .NET classes reconnect. So we saw at least 4 patterns from this list. We saw at least 4 patterns from this list that we are going to extensively use today. Foreign key mapping for connecting 2 different classes. Data transfer object for creating those classes themselves, and then we're going to pass these objects around to different objects, to different functions, different components of the code, so that we don't have to extract out data multiple times. A repository is a mediator between the client and our side of the code, and it is going to be probably a list, and there's going to be unit of work, and unit of work, it is going to maintain that list, and it's going to track what is changing, and it's going to solve concurrency problem. So with that, let's jump into the actual .NET code. So I'm going to close out of this. I'm going to start a new console application. F10 and leave it this. I'm going to leave it at .NET 5. I'm going to hit the create button. Now we got our boilerplate code. I'm going to come here and do some regular cleanup work that developers do. I'm going to leave it at app, and I'm going to do app.run. Let's go ahead and create these two classes. Control dot is going to generate type app, and control dot is going to generate method app.run. Now if we come inside this code, I'll eventually need a constructor, but this is like a good starting point. Now to continue down our example, I'm going to start with a student class. A student is going to have multiple properties, say an ID. Right? If you remember our discussion from the DDL section of databases, we saw how to create a table using the create clause, the create clause of the SQL language, the SQL. We saw that there is a constraint called primary key. Now, if you want to define a primary key in Entity Framework, you will have to define a property like this with ID parameter. There are other ways of doing it that I'm going to show you a little later. In square brackets, you modify it with an attribute. If you mention the attribute primary key, if I remember right, that column is going to become primary key. But if you add an ID property to a class, and there's a way using which we're going to link it to Entity Framework, it is going to become the primary key as well. A student is going to have, say, a first name, and it's going to have a last name. So I'm going to change that to last name. And a student is enrolled for a course, right? But then course is something that I don't want to create over here. And then that goes back to our discussion from database section, where we said that one of the activities of creating a database is identifying entities in the system, and course is a separate entity. We're going to assign similar properties to the course. We're going to say that course is an ID. This is going to become a primary field. A course is going to have a name, and a course is going to have, say, a syllabus, so or list of topics. So we're going to put those topics inside this string variable. Now to link all of this to the Entity Framework, we'll have to explain this to some other component, which is going to know that student is actually going to become a table and course is actually going to become a table, and we want to have some form of relationship between these two entities. If we go back to this discussion and pick up the foreign key mapping pattern of the enterprise application architecture, that is going to say that two entities could be linked. And if you continue looking down, it's going to say that this album itself is going to have an ID property, it's going to have a title, and it's going to have an artist ID. Right? This artist ID defines the ID property of the artist itself. Now, and notice that how it has changed from singular to plural. So the table itself is going to be called albums, right? And this table is going to be called artists. So this is going to be plural, and we are going to establish a relationship between an album and artist using this property. So let's apply something similar in our code, and we are going to say property integer. I'm going to say course ID. Now, so this student is enrolled for this particular course. We would also want to save a copy of the course itself. So we're going to say property course, and we're going to save course value over here. Now, when you're working in Entity Framework, some values could be null, and we put a question mark here, and we put a question mark over here. This question mark is going to indicate that this integer value can be null. Alright, so we know that integer is a value type, and value type is stored on the stack, and it is always going to have value. As soon as you declare this variable, there will be enough memory allocated in the stack for storing values that we can save inside an integer. But then when we put a question mark here, it says that this is now a reference type, if I'm allowed to speak loosely, and then there is a possibility that this course itself is not going to have a value. This is another way of saying in the database language that null values are allowed. You remember seeing this clause in the DDL section where we said null and not null. So this is going to allow null. If you want to allow null values, which is very typical for foreign key references, you will have to put a question mark over here. Along with this, you will have to make a quick change in the project properties. So we already know that it is an exe type, and the moniker of the framework is net50. We are going to add another property here, which is nullable, and I think it is set to enable. Right? When you set this value, Entity Framework and .NET Framework lets you easily work in situations like this. Right? What is this complaining about? Non-nullable property first name must contain an exit in the constructor. Alright, so this warning essentially is saying that because this is a non-nullable property, when we call the constructor of this, full name should have some valid string value. Right? We can suppress this warning through some other tricks, but I'm going to live with this. Let's leave it alone. Right. So we have identified. Let's go back to this diagram. We have identified our first data transfer object, two data transfer objects. First is the student, and the second is the course. So those four patterns we have already seen too. We have seen DDOs and we have seen foreign key mapping. Now each course can have multiple students. So the way that relationship is stored is you're going to have another public property, and you're going to have a list of student. And for this I might have to add a using statement using system.collection.generic, and with that, because I did not declare the null, right? So we have established relationship between these two classes. Now we have to figure out a way of linking this student and course to the database. And the way we're going to do that is we're going to create a class called university context. So let me go ahead and type it again, university context. And this is where these are some of the places where I've seen inheritance to be very useful. You're going to inherit from a class called dbContext, but that class is something that we are not going to define. We're going to read it from Entity Framework, and if I control dot on it, Visual Studio has done some groundwork for me. It went on the internet and figured out that dbContext class itself is present in a NuGet package. Right? We've added NuGet package in the past for dependency injection, At this time, you're going to see Microsoft.Entity Framework Core. It is going to go to the internet and find this package. If you don't get this option, another way is you right click on the dependencies folder. You can also right click on the project folder itself and look for manage NuGet package, or you can right click on the solution itself and say manage NuGet package for solution. So if you want to install a package across all the projects, you're going to choose this. If you want to install it at the project level, you're going to have to choose from one of these two. So I've right clicked on the project, I clicked on manage NuGet package, and instead of install, I'm going to go to browse and search for entity framework, right? And I'm going to pick the entity framework core option. I'm going to hit the install button and click on I accept. With this, in the back, a new folder is going to get added here, which is packages, and inside packages we're going to see entity framework 4, and it is currently at version 507. When you install a package, it is also going to insert a line in the CS file. So if I double click on this, it's going to open the CS file. We saw it on day 1, day 2 of the .NET section, and it's going to insert this line. If you want to switch to a different version, you can change this line and click on restore package, but then a package reference for this particular package with this particular reference number. Right? I'm going to close out of this project file. I'm going to close out of the NuGet package manager, and now if I hit control dot, it's going to give me a using statement. So this using is going to add reference for the entity framework, and now we should be able to resolve the DB context class itself. Now let's go ahead and hit F12 on DB context, and I want you to read through this documentation. A DB context instance represents a session with the database and can be used to query and save instances of your entities. Right? DB context is a combination of unit of work and the repository pattern. Right? You already saw these two patterns. This thing is going to maintain the database inside a list, and unit of work is going to do concurrency management and tracking of changes that are going to happen inside those entities. Right? So unit of work is a combination of these two patterns. Right? So I'm going to close out of this, and now that we know that there is somebody who's going to communicate to database on our behalf, and we want to store information of student and course, we're going to inform that we want those two tables. The way it is done is you declare a DB set of student, and then notice that it has already made it plural for us, like album changed to albums in that diagram. Student, which was singular in the class, has been suggested as a plural of students over here. And one thing, I'll have to make it a public property. So I'm going to copy this and paste it over here, and there you have it. We've defined one way of we have defined one table, the first table of our database. We're going to repeat this. Control E, Control V. It's going to copy the entire line. We're going to repeat this for the course as well. And over here, we're going to change it to plural called courses. Now, with these two defined, let me see if I'm missing something. Right. Now we have defined that our database is going to have two tables. We're going to come and do the next thing of initializing a constructor. Now, the reason we need this constructor is because we already established that for connecting to a database, we will require a connection string. A connection string is like an address, an entry point, or knowing where our database actually sits. And it is difficult to remember those syntax or those class names. So I'm going to go to the parent class, and I'm going to look for a constructor which is going to take DB context options. Now, if I hit F12 on this DB context, you're going to see that it is something that you will have to override if you want to do specific configuration things, right? But for our section today, for our this thing today, for demo, we can live with the default implementation. So I'm going to hit CTOR, which is a code snippet for constructors. I'm going to hit the tab key twice, and I'm going to call the base constructor, which takes at least two objects, um, which has at least two overloads, and one of the overload takes the DB context option, right? And then because we are creating it for the university option, the university context, we are going to pass it an object for which takes an override. So let me go back to this implementation and see if there's a generic overload of this. If it's not, I'm going to define I DB context option. So the class name was DB context option, and notice that it has two overloads. One is a non-generic and the second is a generic one. The way we use generic is we pass it the context object itself, and we're going to call it options, right? The connection string and all the other information of establishing a connection with the database, they'll be saved in this particular object through options, and I'm going to pass those options to the parent class, which is the DB context. So the way to call parent constructor is through base, and this way it's going to make sure that it establishes that connection to the database and comes back with these tables. So now we have done three things. We have defined the DDO. The term for probably C# objects is POCO, plain old CLR object. If I remember it right, it's plain old CLR objects. Right? These objects, they're going to be pretty innocent. They're going to have only the members that are required for saving. They're not going to have much behavior inside them. They're called POCOs for short. The official enterprise architecture terminology is DDOs. So we defined our DDOs, we defined the relationship between them, and then we defined a DB context which is going to establish the connection for us. Now, because we are in the console application, we're going to have to do one more thing, and it is defining a factory. So if you remember our discussion from the design patterns class, we are going to create a factory, and we're going to call it university context factory. So I'm going to pick the same name that we have chosen um, for our DB context, and I'm going to append it with a name called factory. And this is a very trivial code, so even if you don't get it, that is all right. There's something called as I design time DB factory, and it is part of the entity framework. If I spell it right, I design time DB context factory actually. Right, we don't have to remember this class name when we go into the ASP.NET MVC world. So I'm going to add a using statement for efcode.design, and with that added, once again we'll have to keep it generic for the university context. And now I think I did a bit too much. The red squiggly is because we are not implementing the interface yet, so I'm going to hit control dot and I'm going to say implement interface, and it is going to give us an option of create DB context. So we define the DB context, which is going to store the mapping of the table inside the database, but then somebody will have to create the object of this one for us. We don't want to call the university context directly and bother about passing these options, which is about connecting to database. Now, these options, you should not hard code them. Let me go ahead and show you what that would look like. It is returning a university context. The way it is returning this is because we are passing it to this particular object. We have seen a T in the past over here, but then when you put a concrete class name here, it replaces T with the concrete class name. we're going to eventually have to return a new object of the university context. But then this university context can only be created if we pass it option, right? The options that we are setting here. So let me call it options as well. And then this options is something that we'll have to create, and we know that it is already based on what we created here. I'm going to pick up the type from this. I'm going to say new DB context option of the university context. If you remember our discussion on uh, service collection and dependency injection from the solid principles class, you would know that we generally avoid creating an object that of our classes that we have written ourselves. So in the .NET, in the MVC world, we are going to depend on other frameworks which are going to create these objects for us. But for now, we'll have to figure out how to create this particular object. And for this, we have an option called configuration, and information like this, the connection string, we want to save in a settings file. So that setting file itself is in .NET World is called uh, app settings.json. So I'm going to right click on the project, select add new item, and I'm going to choose a JSON object. Now there are a lot of elements here, so an easy trick is that you come to the search box. I generally hit Control E and so look for JSON, hit enter, and it's going to give you one of these files. So JavaScript, JSON config file, I can choose any of these options. They're all going to be JSON. They're not anyway giving me the name that I want. I want app settings.json, and then it's going to create an innocent looking JSON file for us. All I have to do here is create JSON objects, and Visual Studio IntelliSense is kind of helping us here. We want to create connection strings, and connection strings is a JavaScript JSON object itself, and that's why we have these parentheses here. It is not a simple value with double quotes or say an integer. It is a JSON object itself. So I'm going to come over here, hit enter, and if I type control dot, right, we can give a name here. So I can call it university context, and over here I can put the connection string. Now connection strings are pretty tricky to remember the syntax, and I generally once again rely on the tools that we have. So I'm going to open the Server Explorer, and over here you're going to see a connect to database button. Right? We already have SQL Server installed here. There is another trick that I had planned to show you. So I've launched a command prompt. There's a command called SQL local DB. If you have SQL installed on your computer, you're going to get this command. It is called SQL local DB. If you hit enter, it's going to print a lot of things. Now there's an option called info or I for short, and it's going to print an instance name over here for you. So the way you can get your instance name is you once again run that command SQL local DB, and then this time you can pass info or you can pass I, and it's going to show you which SQL instances are available on your computer. So I have MS SQL local DB. I can copy this and try to create that query myself, but the second option is through this connection string, and I'm going to leave it dot refers to your local computer, and then you can pick up a database name, and then this database name can be let me pick up DemoDB. That's where we were working in the past, and I'm going to hit OK, and it is going to start appearing in this data connections list. Now I can right click on this, go to properties, and through properties I'm going to see connection string. I'm going to copy this, and just to ensure that I don't have anything secret mentioned here, I'm going to paste it in Notepad. Okay, there's no secret here. There's data source, there's an initial catalog, and there is integrated security. I'm going to copy this. If you're connecting to something on the internet, you might have to pass, say, username and username assigned to something, and you're going to see it here in plain text, and then the password as well. And the password will be saved here in plain string as well. So this is pretty unsafe, and There are ways in Azure which is going to make this a little safer for you to work with. But this is for this queries, this connection string that we pasted here is for SQL databases. Remembering this connection string syntax is extremely difficult because there are uh, there are a lot of databases. So there is a website called Connection String where you can go and look at connection string for all the databases that are there. Right? So this is Azure SQL DB, this is Access DB, this is Excel. You can save your data in Excel as well. There is SQL Server, there is SharePoint, any database that you can think of. You're going to see multiple examples of their connection strings. So let's go to SQL Server, and SQL Server can be connected using .NET libraries, another DB provider, OLEDB, and then ODBC driver, and other wrapper classes as well. So these are similar to Entity Framework. If I'm allowed to speak very loosely, they are going to give you option of connecting to the database, and there are multiple ways of connecting, like standard security, trusted security, using server instance, non-standard port number, uh, and using IP addresses, right? So choose the one that works best for you and for your database and for the framework that you are interacting with, and you're going to get a good help from this particular website. So let's close out of this. We have our connection string mentioned here. Now we're going to establish a relation between this, excuse me, this JSON file and this particular configuration. So the way to add that is you're going to use a CLR class called configuration builder. Right, if I hit control dot, it's going to suggest me the package through which it is going to come. So this is the second package that we are installing today. First we installed Entity Framework Core, and the second is configuration management. With this reference added, with this, it turned green, the red squiggly is gone. Now I can hit control dot and I can say add JSON file. The JSON file reference should have come through based on the configuration package. So there's something called as add JSON configuration, and then to this JSON configuration we're going to pass the value of app settings.json, but then for some reason it is not picking up app settings.json. For some reason it is not getting this, so give me 1 second while I resolve this. Configuration. Let's look for another NuGet package. I could call JSON configuration. So I think there is another extension that we'll have to install along with Microsoft.extension.configuration. For JSON, it has been separated out, and probably this is a good time that that I explain another .NET Core concept. So .NET, the framework, and .NET Core, they are different in that .NET Core is rewritten, and while they were rewriting .NET Core, they created multiple smaller consumable packages. When you include a DLL or a reference in your project, something like this, right? It comes with all the functionalities that are available in that particular assembly. You would not always want to have that level of granularity, right? There are smaller chunks that you are going to divide your application in. It is like the interface segregation principle. We could have written the read message and write message function together inside one interface, and we could have called it iMessage, right? But then we created two separate interfaces, one for message reading and one for message writing. When you divide your application in smaller consumable chunks, you will have to create smaller components that you can consume individually. This configuration here comes with basic configuration, right? But then if you want to read from JSON, you will have to include another package called .json, and this package now is going to give us the add JSON file. Okay, right. And let me go ahead and hit F12 on this. And once again, extension function is going to be, the class itself is static, the function itself is static, and the first parameter that it takes is this. So this is an extension method. It is going to have its own icon, a cube with a down arrow. If I can see it right. And over here, now I can give it the app settings.json file. Right? And it's going to pick up settings from this particular file. It's going to come to this configuration, and through this configuration, we'll be able to pass it the option that we were looking for, right? So to create this option, we have everything that we require now. So we're going to come to configure, and this new db config option, right? It has a method. Alright, so I am using an incorrect implementation. What we need is an options builder, and it is called new db context options. And notice that there is another overload called builder, and to this builder we're going to pass the university context. Now on this builder object, I can call another function called, depending on what database you want to support. Because we are using the SQL Server, I'm going to call the use SQL Server option. By control dot options builder dot use SQL Server, and over here I'll have to pass the connection string object. So the connection string object itself is going to look like configuration, and then over here I'm going to say this hierarchy, connection strings dot university context, right? I'm not going to, so I'm going to copy this connection strings, and instead of dot I'm going to hit colon, and then I'm going to pick up the context name itself, which is context, and we're going to have to resolve this. To resolve this, I will probably have to add another package, manage NumGet package, and I'm going to search for entity framework for the SQL Server. I'm hoping, right. So entity framework core is going to give us the basic functionality. If you want to interact with SQL Server, you're going to have to use this. Postgres is another relation database. If you want to interact with Postgres, you will have to install this. So we're going to go ahead and install the one for SQL Server. And I think it is installed. Close out of this, hit control dot, and we might have to add a reference. Okay, I accept, delete this, and with that reference added, it is kind of resolving the use SQL Server for us. And over here I'm still not able to read the setting. The setting itself is configuration, and then in these square brackets we pass it the string constant. Now I don't know what it is complaining about. Configuration is not null here, which is good. I'm going to say connection strings colon university context. What is the error message? Cannot apply indexing to an expression of type I configuration builder. Alright, because I did not call one function, it's called build. So it reads to this uh, JSON file, and then through build it becomes the iConfiguration object. If we go to this definition, you're going to see that it has an index operator. This index operator is going to is going to link to that JSON setting. With this created, we have a mechanism of creating the DB context object. We are not going to directly deal with the course and the student object. We are going to run it through the university context. So now with this initial setup completed, we have our databases, but if we let me launch the SQL Server. Right? We have these classes, but we don't have corresponding tables for these two databases inside our DBMS. So if I open up this DB and we were in the demo DB, we don't have a table that points to student and the courses. So to provision those two tables, we'll have to add migrations. We'll have to specify how to create a table for these two particular DTOs. So it is already 9:07 on the clock. Let's take a quick break. We'll come back in exactly 10 minutes and resume our session. Right? Thank you. the version of the operating system, and the version of the CLR itself. Then it is showing SDK, which is software development kit, the runtime that is installed, and what options, what activities are available to us through this .NET installation. If you want to interact with Entity Framework, there is another switch which is called EF, .NET EF. If you run this, you're going to see output for the Entity Framework. If it is not installed on your computer, you can install .NET EF install hyphen global. There is some switch through which you can install this particular command. What we want to do is go to this folder structure from our .NET code and open it in command line. The second option is there's a console that is available to us. This console links to the current folder structure, and we have the same command options available here as well. So I'm going to run our first command, which is .NET EF, and we want to migrate the classes that we have created to the database. And the option for that is to add migration. Before that, I want you to point to the current folder structure. What we have is program.cs, app.cs, and the app settings JSON. I'm going to run the migration command, and I'm going to give it the add option. I'm going to say initial create. Generally, this is like very standard command, and then it is saying that no project is found. So to give the project option, you will have to provide hyphen project option here like this, and then mention EF demo. And sometimes this indicates, so this indicates that the project has not been compiled. Use .NET to resolve errors, and there are compile time errors in our application. Let's say that configuration is not present. So when we resolve this, we see 2 more errors. We had packages added here, right? The JSON package. Okay, so it shows that it is installed. Let's look at the project configuration file, and even here it says that it is installed. So my item application is not compiling. So let's go ahead and do a cleanup, and let's force a rebuild. Saying type or namespace configuration builder could not be found because there's no using statement. If I hit control dot, add the using statement back, I don't know, something is off, but it's fine now. Let's go ahead, hit control L and run our second command again, the original command again. And then now the build has succeeded, and notice something changed in our folder structure. I think it is plural migrations. Alright, so your startup project EF code does not have a package. So it is saying that we do not have a package called design. Now I told you already that .NET Core is all command line, and you can install packages using command line tool as well. So everything that we have seen so far, that right click and go to manage NuGet package, come to browse and add package, we can do that same work through the console as well. So let's go ahead and give this thing a try, and I want to install it in the EF demo project. So I'm going to specify all those options and hit run, and it is completing. So let's not try that. I might have missed some option, but then it is essentially saying that we need to install this package. And when we install this package, I think the option that I gave was incorrect. Instead of add, it should have been installed. Anyway, so now that this package is installed, if we run the migration command once again, .NET EF migrations add, initial create, and the project name. I'm hoping that this time it's going to get through. And it succeeded. Your startup project does not have reference to Entity Framework design. I don't know why it does that, but Let's go ahead clean, and after clean we're going to do rebuild, and let's give it another try. And it is completed. So it is saying that the tool that I have, 506, is older than the runtime, which is 507. For Entity Framework to work, we'll have to install those tools. So let's go ahead and run that command, .NET EF install, or there is an update command as well. So I pulled up this part of documentation, and it is going to tell you how to install those tools. So it's .NET tool install hyphen global EF, and I think on the similar lines there's an update command as well. So we're going to copy this command and run it here. Then it has successfully upgraded from 506 to 507. Now we should be able to hopefully run this command this time. File not found exception application.json, and this was not planned, but when you add files to solution like this, they only become part of your solution. What that error message is saying essentially is, if you go to the output folder, bin debug framework, it is saying this is where they try to run the application from, and the app settings.json file is not present over here. And to do that, all you have to do is come here, go to properties, and it says do not copy to the output directory. We are going to pick one of these two options, like copy always or copy if newer. Copy if newer is just fine. So it's going to compare two files, and because we just saved it, and when we do that, there's something that happens on this file as well. So it is saying that app settings.json preserve newest, right? And it is going to copy to the output directory. So as we are going to interact with Solution Explorer, the CSproj file is going to make changes. And if you don't have the flexibility of Visual Studio, you can hand code this particular file, and you will still have the same effect of Visual Studio. Once again, I'm going to clean, I'm going to rebuild, and with the rebuild, we are going to see the app settings.json file here. This was missing earlier. With this file added, this is like the 10th time we are running this. The migrations, it should go fine this time, please, come on. It is saying that no database provider has been configured for this DB context. A provider can be found using overriding this particular thing, or by using add DB context on the application provider. Right. I don't know why it is doing that, but let me go ahead and in the run function, now I'm going to call two functions, two statements. University context factory, and this factory is going to give us the DB context. So I'm going to save the context here with factory dot create DB context, and create, it was probably not DB context. Create DB context is going to take a parameter. We deposit the arguments, or because we don't have arguments, I'm just going to say empty. It wants a collection. So let's go ahead and start passing these args to the run function. We're going to receive string collection in the form of arguments, and we're going to simply pass those arguments here. And I'm not sure, but let me go ahead and run this code. I'll have to debug this code. Just give me 1 second. Just gonna copy this error message. And I'm gonna search the error message. And probably they should be able to, they should give us a solution. Right. Saying that the error message says your log manager context needs a, so we have this constructor added already, HTTP accessor. This obviously is not add singleton. I don't know. Let me go ahead and add this class on the DB context that we have. The DB context, I'm going to override this function. It's going to take the builder and set base path. For directory, I might have to add a reference, system.io. It got the current directory, it picked up everything, and probably this should fix it. Oh, come on. Value cannot be null. So it couldn't find the connection string. If I can go back, let me go ahead and change this to default connection, and it should have worked. Default connection. I'm gonna set a breakpoint here. Hit a 5. Not a 5. Right. So it has at least one member, and that member is app settings. The data itself is the connection string. Right. The key is connection string, and the value is this particular database. Right. So we definitely have a value here. The option builder is building the option, and then the university context is receiving that option. And then now if I return this, application runs fine. The parameter connection string is null. I have absolutely no clue about this error message. I'm gonna have to do some more error checking. Parameter name connection is string. So I think we are doing everything needed here. Hmm. Alright, so I wanted to show it to you in the console application. We're going to skip that step and let's go ahead and do that in the MVC application. Let's ignore just ignore the MVC part. MVC makes adding entity framework pretty straightforward. I created a .NET Core MVC5 project. Over here, I'm going to add reference to entity framework core like so. Then I'm also going to add a reference for entity framework core for the SQL Server, this package. Right. So with these two installed, it takes a little while before it's done. So right, accept. And we are also going to do a little bit of designing. So let's go ahead and add that package as well. Right. So with this, these three packages have been added to the package. Now, these two projects, they are almost the same. We need to copy our Coco classes, our DB context class, and probably we don't need the factory this time. So I'm just going to cut this thing out, and in the models part, I'm going to add a new class. Just leave it alone like this, and over here, I'm going to replace it with three classes, the student, the course, and the DB context. Now it is complaining about DB context, control dot, I'm going to add a reference. That is going to resolve it. And then iConfiguration root is going to give me this iConfiguration object. Right, and directory comes from system.io. Right, so I think we are good here. Now when we added the NuGet package, we now have an option of configuring the SQL Server through these services. I'm going to say add SQL Server. Dot add DB context. I don't know, university context. And probably this thing is going to take a couple of options. So in the options for university context, I might have to add a reference. And these options, they are going to be options dot so there's a way we can specify the options builder. So we're going to pick that sentence, pick that statement from the SQL documentation, and it is going to say that you want to add DB context, and on the options we're going to say use SQL Server. So it is the same statement that we were adding the last time as well. Options dot use SQL Server, and for this we might have to add another using statement. And once we have this, we should be able to use the configuration object here, and to this configuration object we can say get connection string, or once again we can pass that square bracket value. We have not added any configuration section, so let's go ahead and pick the same setting that we had here in this file, and I'm going to save the connection string, add the connection string in the ASP.NET MVC app settings project. With that added and this thing defined, we can now fall back to this statement, and this configuration starts with a capital C. Right? This should initialize our DB context option. So the command that we were trying so far, let me set this as the startup project, and over here control dot, and this time we can change the project to web application 1. We don't need control and dot. If I hit enter now, hopefully the build failed. So let's go ahead and build this now. Design, I think we added the design package. That is right here. Okay, so it should be entity framework core.design, not SQL Server.design. I'm going to ignore this, and over here once again pre-build. So the reason we see that error is because this restore command needs to run. The restore command gets all the NuGet packages and it updates that reference, and it is because of that running that we can get rid of this error. So we're going to run initial create once again. Right, so it is done this time, and now we should be able to see a folder called migrations. Alright, and it is through this migrations folder. It indicates two things. Let's go ahead and look at the initial create. This was the name that we specified. Over here, now it created a new class, initial create, inheriting from the migration class, and it is overriding the up function. When the database goes up, it goes ahead and creates a table. Now we have two tables in our solution. One is courses table and one is student table. If you look at these columns here, it is adding multiple columns. These columns, they are going to have the same schema as those classes. It went ahead and added a primary key constraint under the constraint and called it pk underscore student, and it is assigning it to the ID value. There's a foreign key constraint as well that's added for us, which is between student and courses, and it is linking the course ID column from course ID to student, or the student table has a course ID column and it is linking it to the primary key of the courses table. So this looks a lot like the DDL section that we saw where we were using the create table command. It is going to do that for us programmatically. And now if we go to the SQL Server and refresh table section, I was hoping that we were going to see student and the other table. So let's go back to DB core, DB migrations. So the only command that we ran so far is create migrations. Migrations is going to generate that code. The second command is .NET EF for entity framework, and then database update. So everything that we have created those files, this update function, this update command here is going to call the up function, and it is going to provision those tables for us. Once again, we'll have to specify our project, and I want to give it another shot, but that's alright. Let's go ahead and select web application 1 here, hit enter. And now if we come to our database to refresh, it has created those two tables for us. One is the courses table and the second is the student table. And then if you look at the design of these tables, it will have those columns, first name, last name, and the course ID. And then course ID, if you remember how to pull these values up, course ID is going to point to this particular table. Alright, and then there is another table that got created. It is called EF migrations table. So I'm just going to show you the values of this table stored in this table, and it is a migration, and then this was initial create as one of the parameters that we passed to the migrations command, and this name here matches exactly with this particular class name, 2021 June 25th 04 15 31, right, 04 15 31. So every time you come and add this, it is going to store a reference to this particular table. Now we can go ahead and modify, add more members to our student class, and every time say uh, what class he is in. So class is a reserved name. For if you want to use reserved name as a member, you can put an @ sign in front of it. But let's change this class to grade, right? And let's get rid of this semicolon. When you modify tables like this is similar to adding columns through the alter table command, alter table add column. It is similar to that, and every time you modify the DTOs, you will have to come and do the same exercise again. You will have to use the add migrations command, .NET EF migrations add, and then instead of initial create, you're going to be more descriptive this time, like grade column to courses, and then you specify the project name, and then once that is done, you once again run the database update command. This database update is going to fire up that migration, and it is going to keep the tables and entity framework in sync. So with that defined, now we don't need these two classes. We can switch back to entity framework core, and I'm going to make this as startup project once again, and go to our app.cs. Inside app.cs, now if I hit F9 to a little bit of debugging, we are going to see that the context is probably created. Shift F11, F10, and we're going to have a context object. And context object has something called as change tracker and those two tables, the courses and the student table. Now let's go ahead and start adding value through this context. To access the student, we are going to use the student's property. It is added inside the university context through this dbset. Let's look at this dbset first. dbset is inheriting or extending iQueryable, IEnumerable, and iQueryable non-generic as well. We know that IEnumerable gives us at least one method called getEnumerator, and it is going to come in handy when we want to use it inside the for each loop. iQueryable, it creates queries and goes to the database and executes those queries for us. So dbset is going to give us a collection that we can use inside for each loop. Now if I come here and then to students, if I say .add, right, it is expecting a student entity. I can give it my name. I'm going to be the first student here, and let's go ahead and declare that member here, new student. and over here I can provide multiple values. Let's go ahead and populate these columns. The first name is Sia, last name is, I'm not going to give it the ID, and because there's a course as well that we want to add, I'm going to go ahead and add the course as well. I'm going to call it full stack developer, and this is the course. The course itself, we are not going to give an ID once again. We're going to say full stack developer, and because we are inside the square parentheses, we're going to pick say C# and HTML, CSS, and JavaScript. Right, a semicolon here. The way we added student, we are also going to add to the context the course dot add. I'm going to mention FSD, short for full stack developer. And once this is done, we are going to say context dot save changes. Okay. Now, if we go back to our discussion of these three, we started with the discussion of unit of work and repository. Now, this repository is kind of saved inside this DB set. Remember the definition that it says that it's a collection-like interface. That collection-like interface in Entity Framework is called DB set. And the unit of work, it says that it maintains list of objects, and writing out of those changes is a responsibility of unit of work. In this pattern, the official word is commit. We are replacing commit with save changes. So we have done all four things. We have defined the DTO, which is POCO in C#. Those POCO objects, they have references that are pointing to other objects. So if I want to enroll a student to a specific course, I'm going to assign the course object to that particular student. And over here, I think it is okay because I won't have the course ID yet. I'm going to leave that course ID field blank. And hopefully the save changes is going to work. Let's get rid of all the breakpoints. I'm going to hit F9, hit F5. And the factory created the context factory for us. We got the database object. We initialized the course, we initialized the student, and then we informed Entity Framework that I want to add this student with this course, and it is going to give an error message saying that the connection string is still not found. Obviously, I'm so sorry. So it was, let's just go ahead and on configuring, let me pick up this hard-coded string. I would highly discourage you doing this, but let's run it again. We found the context, added the student, and now when we try to add it to student, this time it got through. We did not have to create that MVC project, but that's all right. We modified the data that we wanted to save in the memory in the collection like data structure, and now with save changes, if I hit F10, it got through. Now if I come to these tables and say get me a list of all these students, right, I see myself and I see at least one course added to this particular structure, right? There are a couple more things that I wanted to show you today. So if you guys are okay, we can continue with the rest of the session for like another 20-30 minutes. Should we go on?
Yes, yeah.
Alright, okay, so now that we know that context is storing these values for us and it is persisting these values, there are multiple things that we can do with our application. Uh, and the first example that I want to show you is of give me 1 second. Right. All the CRUD operations that we saw in the database, we can now start noticing them over here. Now, I'm going to comment out this code here, which is for adding to database. And instead of this, I'm going to create a new student. And to this context, I'm going to say that from students, uh, get me like the first object. So if you remember our discussion on the lambda expressions, I'm looking for an example of the lambda expression that we can use. Right. So I'm going to put the where clause. This where is going to require system.linQ, and with this I'm going to get student s over here, and if I give it an ID, let's go back to the database and notice that the ID of myself is 1. So if I want to select a student with ID 1, I can come and select that using the where clause. Now, one trick that I can show you is the override of toString is very effective. So just come here, type override and toString, and because typing out these values multiple times is uh, very difficult, at least for complex type, we are simply going to say that I'll put the ID here, then space, first name here, and last name here, like so. It is going to extract out this information, and when we use the write line statement, it is simply going to print out the code for us. There is only one problem to this. If you hover over it and if you look at the return type, it is returning an iQueryable. An iQueryable is only present inside an expression form. It is not yet added as uh, it has not yet went to the database and fetched the values for us. A query needs to be executed, and the way to execute that is you call the toList function, or there are a couple of other functions. I'm going to put them here in the comment part. If you do .any, if you do .single, or if you apply some other operations, like we have seen select count star, and there are some other aggregate function like sum. Right? If you call one of these aggregate function, it is going to execute that query. The second option is that you put it inside a for each loop. The for each loop is going to force the execution of a query, and there is yeah. So these things, they're going to trigger the get enumerator function, and when that happens, the query is kind of executed on the system. Now, I haven't tried one thing, but it is related to adding logging to this particular system. So let me go ahead and quickly pull the logging part and to the options builder, where we are giving it use SQL Server. We are also going to give it one more option, which is related to logging. right? And then log factory needs to be configured. So we added that package, and everything that this application is doing now, it is going to so once again, this is the default logger. We want a logger factory for console. So that should be available as its own package. I'm hoping. So the add console is not available. What type? Right. Core, login builder, and console. Right. So a lot of things have changed since I last used them. With this package added, I think it should resolve now. Right. Now I'm going to show you something interesting. So with this statement over here, we are going to put a breakpoint, hit F5, and I'm going to hit F5 again. So the breakpoint is going to jump from this statement to this statement, and I did not log anything. So there's a special place where you can see all the SQL queries that are getting generated. I wanted to show you that when this thing is getting executed, there's a SQL query that gets printed on the screen. Right? What we have done instead is we have printed the collection type. This is because this student here is a list of students actually. So to get that right, we are going to run a for each loop of sn students. Let's make it plural, and let's move this line inside and change this to s. So you're going to get a list of all these students with this matching ID. We know that there's only one. So if I hit Control F5 now, it's going to come and print the two string from the student class. The first name is Zia, last name is Khan. So we got the only record that we have in that system. Now, because very soon it becomes difficult to generate a lot of data, there is a quick trick that I can show you. So if you want to generate a lot of mock data, you can search for mock data generator on the internet, and this mock data generator is going to show you generally some resource which is going to fix a lot of things for you. So the field name itself is first name, right? This field name here is last name, and the type here I can search for, say, name or first name. Right? And this last name is fine. I don't want the ID column because ID is something that can automatically be generated. I don't want email, gender, and IP address. It is going to generate 1000 rows for us, and it is going to generate formatted in CSV format by default. But then I can come here and I can pick up the SQL format as well, and there's a nice preview option. So if I click on this, it is going to preview 100 rows to me. I'm they're calling it mock data. Let's go ahead and change that. I'm going to change it to student. Let's look at the column name once again. This is, as it is plural, students, so I'm going to say students here. Once I say preview, it's going to show me that in the student table it is inserting first name, last name, and this is the data. I can close out of this and I can download the data. It's going to download a SQL file for me. If I open this, it launched a new instance of SQL. I'm only interested in these SQL queries. I'm going to copy this, close out of this, and go back to our SQL server. I'm going to hit a new query, make sure that I'm in the demo database. If I hit F5, it is going to insert those 1000 rows into the table. Now if I come to students table and hit F5, I have about 1000 students present here, right? With the course ID is not populated. I don't know, that is fine because we have anyways marked it nullable. So with these rows added to our data, now we can play around with this particular statement. So we want the first name dot contains is a C# feature which is going to let you search inside this thing. So contains, I'm going to say AB, right, like this, or probably starts with, I'm going to say AB. I don't know if there's anybody with this particular name, but then it starts with, and this is returning a boolean. Okay, so this has to be double quotes. And now if I run this query, it is going to get me all these students with that particular name structure. Alright, so there's Abdul, Abe, Abram, and AB. We have some data, some decent amount of data to play with. But then there are two things that you will have to notice, that the data extraction for us without queries has become about passing lambda expressions. And that's why knowledge of func and anonymous functions is so important. This student is becoming a filter. When the query gets executed, it gets to this function and it says that, hey, give me the filter criteria using which you will want to format. And then once that filter is applied, it gets the to list and it returns the set of students to us. Now I can modify this student value that is coming from this collection, say index number 0, and let's change the name of the student from whatever it was to my name and hit a 0 here. Student dot, I'm going to say first name, and I can assign it a string. And now if I call save changes, let's go ahead and we'll modify it after we see the ID of it. If I hit Control F5, it's going to come back with those 4 students. Student ID was 179, right? Let's go to our database and run this query once again and jump to index 179. So 179 is here and the DB update has happened for us. Now I couldn't show you the SQL query, but then we're going to see that again once we are in the entity framework section. There was only one query that got fired and it had a where clause in it, where ID equal to 179, and it modified exactly one field. So the query that went in was almost like update students, set first name equal to 0, and there was a where clause where ID equal to 179. We're going to see this very shortly in a couple of days when we are doing entity framework again in the ASP.NET section. But then this is a super efficient query, and entity framework can generate this kind of query. And the way it does that is when we come back with some data, entity framework saves 2 copies of this. So let's now go ahead and look at that. I'm going to go back to context. I'm going to search for something called as entry. I'm going to pass it, probably it is the student that I have to pass. And let me look up the syntax once again. So to this entry, I'm not going to pass the student member here. I'm going to pass the object itself, and I'm going to search for state. Right? Let's set our breakpoint over here on this line. I'm going to save it in a member called state. Let's hit F5. It went ahead, it got those. I'm going to get rid of this breakpoint. Now it is waiting for us over here. Now let's look at the state value. It is saying unchanged. It is unchanged because we have not changed the value so far. I should have done that before. But if I run this code again in the immediate window, I'm going to have to delete var. State is modified, right? So when we don't touch a member at all, the state is unchanged. When we modify it, the, only this parameter is modified. Let's observe a couple of other entries that we have, and I'm going to come back to this immediate window, and over here we got like 4 results. This one is unchanged, right? Let's go ahead and declare a new student, assign to a new student, and I'm only going to give it like first name, and I'm going to call it Z once again. I think it doesn't like putting a var keyword here. Okay, so I might have to use Zia. Zia was not part of this collection, so let's go ahead and run this part of checking state. Instead of student 0, I'm going to use the object declared on line number 29. I'm going to say state. If I hit that, it is saying detached. So we saw at least 3 states. One is unchanged, one is detached, one is modified. Modified occurs when you take a member and you update the value of it. Detached occurs when there is no connection between the object and the DB context. And unchanged is when we take the value and don't do any modification on it. Now we're going to do something over here. We're going to say context.entry context.add, and over here I'm going to pass Zia once again like this, and I'm going to hit enter. So this entity has been added with some foreign key reference, or probably not, probably with a foreign key reference. But once again, let's go ahead and print the value of the state here. When we do that, it is added, right? And now if we do save changes, the application completes, but this record has already been modified to Zia. I'm going to comment this part out, and I'm going to run this query again. And if I go all the way to the end, because it is selecting only top 1000, I'm going to get rid of that. I'm going to hit F5, and now if I go all the way to the end, we see record number 1002 added, which is course ID 2 that we created like some time back. Make sense? So Entity Framework is doing 2 things for us. One, it is letting us interact with the database system, and it is also tracking which objects are getting modified. And if we go back to the design pattern that we started our session with, delete, close, and over here, unit of work has 2 responsibilities: writing of changes and resolution of concurrency, and the repository pattern has a responsibility of giving collection-like interfaces for addition and of the elements. There was right. It maintains a list of objects affected. I wanted to show you this. This management, this occurs when we start using the context class, and this is a property of the unit of work, that the objects that are getting returned, they are saved and dragged through this entry collection, and that's what makes Entity Framework a little inefficient. But then that inefficiency is required because at the end of the operation we would want to have some form of awareness as to which all entities got modified, and then it is through this tracking that Entity Framework generates those efficient select update like queries and insert queries. So when you are modifying the repository, which was a DB set, you were adding elements and deleting elements from this. It is getting tracked at the unit of work level. And now probably you will understand what this little comment here means. It says that it is a combination of unit of work and the repository pattern. It is doing both the activities inside one single class. Right? So this is part of the entity framework. There are other things that you can notice as well. This change tracking is not always required, and if you run into scenarios where you don't want any form of change tracking, the option is pretty straightforward. All you have to do is come to this students and then use another overload called as no tracking. If you call this function, now you are not going to, okay, let's move this line above and put the breakpoint at this line now, probably on this line, right? We have intentionally turned off tracking because we wanted some form of performance. So we're going to get to this point, and now if you look at the state, it is saying detached, even if it is part of the DB context. Remember from our immediate section that it said detached when we tried to connect this object Zia here with a DB context, and they had no connection here. But then when you turn tracking off, it is not going to have any sense of this thing. With this, if I now come and let me go ahead and add to the context one more time this object here Zia, and then once again Zia and this DB context has no connection till I run this query. If I run this, even then, okay, it gets added here, and probably I do not want to show this. I wanted to once again show you this particular object. So now that this thing has been updated, the query that is going to run because of no tracking is not going to be this, that only first name got modified. It is going to be a little different, and this time it is going to save the first name, the last name, the course ID, everything. For that particular student, there's going to be a where clause, but then it is not going to update only one field, it is going to update the entire set of columns that are there in that particular object. Okay, so there are ways in which you can make entity framework work more efficiently, and one of the trick is knowing stuff like this, that how you want to perform tracking of the objects that you are receiving. So this was one thing. There are options of running a raw SQL on the context object itself. I'm going to hit F5, run this, finish this to completion. And then if you want to run raw SQL, which I would highly discourage, you have an option through the option name is from SQL interpolated, and over here you can give a SQL statement. Right, you can do select star from something, from say students, right, and where first name, and then you give a like statement, and the like statement is going to have some expression over here, and to give that expression I'm going to put a dollar sign, and I'm going to say var filter. I think control shift U is going to make everything, control U is going to make everything small, and I'm going to put the filter here. Once again, control U is going to make everything small, right? The only problem with this statement is, okay, it will require a student DB. The only total problem is that if your filter statement is some tricky clause like this, delete star from some table like students, right, you are exposing yourself for SQL injection attacks, and that's why this is extremely bad, right? You don't do this, never. All right, so this is one option that you can directly run raw queries using from SQL interpolated. And one last thing that I want to show you before we call it a day is something called transactions. Now, transaction runs around multiple tables. I mean, that's how I interpret it. And if you want to support transactions, you will have to use another syntax. So far we have been dealing with context dot, instead of the table name that we were using so far, you're going to say database dot, and then you'll type transaction, and it is going to give you multiple options. You can begin a transaction, and you can commit a transaction, and you can roll back a transaction. So these are like three actions. At the beginning, you're going to call this function. When you have done everything successfully, you're going to call commit section, and in case of exception, you're going to roll back the transaction, right? And when we have such conditions, we generally use try catch and finally block. So we're going to put a finally block here, right? And to begin a transaction, we're going to say context dot database dot begin transaction. That's going to mark the beginning of it. When everything in that transaction completes, like updating a student information, like you get these student information, so I'm going to repeat the same line. You probably modify one of these students, like so, and then you save the changes, like this statement over here. I'm going to call it students2, right? And in case something goes wrong, you're going to pick up this code and you're going to say rollback transaction. And in the finally block, you can probably dispose of the object, like context.dispose. Then we saw another pattern for dispose, putting everything in the using statement. And this is going to take care of transaction management for you. And then in transactions, you generally don't have one table, you would have multiple tables. So you would, in some form, also want to interact with the courses table. So I'm going to call it course context dot courses, and this thing is going to get you all the courses. You might have to do a to list here. All right, to list is going to execute that query, get all the courses in this list, all the students in this list, and you can modify these, and this should be commit. Sorry about that. Right. When everything, all the modifications are done, save changes goes above. You save the changes. If everything works out fine, you commit the changes. If you're in the exception block, you roll back the changes. So this is going to make the courses and students modification as a single atomic unit. And I hope you remember our discussion from database, which was the asset properties. We want atomicity, consistency, isolation, and permanence. So they're going to be available across server restarts. So to maintain the consistency, these two should be updated together. And when you have such a situation where you want to update multiple tables together, or you want to fail them together, you use transactions. And transaction management in Entity Framework Core is pretty straightforward. You use these three functions inside a try catch block. There are better techniques that I've not shown you in this session, but then as we work towards the ASP.NET section, I'm going to bring that to you. Uh, Once again, if I have to give you a little clue into this as to how we're going to do that, look at this word here. This university context. The question is this university context common noun or proper noun? And the answer is proper noun. Another proper noun that we have been using in this code is Entity Framework. And using proper nouns in our code is violation of multiple principles, include the first of all is open close principle. Because we have so tightly coupled to the Entity Framework, right? Even through a factory pattern, we are very, very tightly coupled to Entity Framework. And I don't kind of like that. Right? We would want to have some flexibility of switching to different provider or to a different database altogether. We know that relation databases, they are only suitable for certain scenarios. If you want to switch to another non-relational database, you would want to have that flexibility. And if we are so tightly bound to the ORM and to the database, we are taking away that flexibility. And to introduce that flexibility again, we are going to create our own unit of work and our own repository, and that is called the repository pattern and the unit of work pattern. And then inside this unit of work and repository that we are going to write ourselves, probably in the future lectures, we are going to tuck all the other providers inside them. So our app class, it will have absolutely no clue where the data is coming from and how is the internal tracking being managed. All right, so with that, we're going to bring our session for today to a closure.